Hello, this question is quite challenging. I would recommend you to stop the video, give it a go, try it, and then carry on watching. This video is going to have three parts. In the first part, we are going to determine if this molecule is C or Z. In the second part, we do the same thing in a skeletal formula, a different molecule. In the third part, we go through the exam question. In the video description, you have the times for each part, so you can skip parts of the video as you wish. Okay, so is this molecule E or Z? Well, we are going to apply these rules. If you want to, you can stop the video and read them. I'm going to go through them anyway, so it's up to you. Perfect. So what we have to do is we focus, just one second. There we go. We are going to focus on the carbons of the double bond. So you focus on this carbon. What is it bonded to directly? Well, it's bonded to one fluorine atom, and it's bonded to one carbon atom. And now you compare these two atoms in terms of atomic number. So you get your periodic table, fluorine, carbon. Fluorine has a greater atomic number. So then fluorine is going to be priority 1. And the group at the top, the whole ethyl group, is going to be priority 2. Okay? And now you do the same with the other carbon. What is it bonded to? It's bonded to one hydrogen, and it's bonded to one carbon. So I think for this one, you wouldn't need the periodic table. This group at the top is going to be priority 1, and this group at the bottom, priority 2. Yeah, perfect. So now what you do is you draw a line like this across the double bond. And you can see that the top priority groups, they are on opposite sides of the double bond. When they are on opposite sides, that means they are enemies. Enemies means E isomer. If they were on the same side, then they would be Z, but that's not the case here. Okay? Perfect, so let's have a look at the next one. So this carbon here. Well, maybe you may want to know that when you have a double bond in a skeletal formula like this, then this carbon is bonded to one hydrogen, and the hydrogen is at the top, is here. Or if you have a double bond like this in a skeletal formula, then there is a hydrogen at the bottom. Yeah. And the reason is that the shape of this carbon is trigonoplanar. So you have a triangle kind of thing. You have 120 degrees angle. Yeah. Okay. So we focus on this carbon. What is it bonded to? It's bonded to one hydrogen here and one carbon here. Which one takes priority? The carbon. So priority 1, priority 2. And then this carbon, what is it bonded to? Well, it's bonded to one carbon here, which is bonded to 3 hydrogens. And it's bonded to another carbon here, which is bonded to 2 hydrogens and 1 carbon. Perfect. So then what happens in this example is that the carbon of the double bond is bonded to 2 identical atoms, 2 carbons. So when you compare them, you get the same thing. That means you have to look further down in the chain. This carbon is bonded to 2 hydrogens, and this carbon as well. But then this one is bonded to 1 carbon, whereas this one is bonded to 1 hydrogen. Therefore, the top group is priority 1, and the bottom priority 2. And then you can do the same with it before, so you draw a line here across the double bonds. And we can see that the top priority groups are on the same side of the double bond, so this is set. Okay. Perfect, so then maybe you want to pause the video now and try A. I'm going to go ahead. So this carbon of the double bond is bonded to 1 hydrogen here. It is also bonded to this carbon, so this is priority 2, this is priority 1, and this carbon here is bonded to 1 hydrogen, priority 2, and 1 carbon, priority 1. And therefore we can see that the top priority groups are on different sides of the double bond. So this one is going to be E. E. Okay? The second one, B. So for B, we do the same thing. This carbon is bonded to a CH ring, and also is bonded to this carbon, which is bonded to another carbon. And therefore, this is priority 1, and this is priority 2. Whereas the other carbon is bonded to one hydrogen and one carbon. So priority 1, priority 2. So then again, this is going to be E. Yeah, okay. Now, if you want to pause the video and try C, see what you get. So I'm going ahead. This carbon is bonded to a CH ring, and it's also bonded to a carbon, which is bonded to another carbon. So this is priority 1, that's priority 2. And this carbon is bonded to a carbon, and it's bonded to a hydrogen. Priority 2, priority 1. So the top priority groups are on the same side, therefore this is E. Okay, so, sorry, this is Z. This is Z, which is the answer. Perfect. If you want to try D, for D you should get E. Yeah. Brilliant. So that's all for today. I leave you this quote in case you like it. Yeah, that's all. Bye-bye.